So now we've just been doing analysis in the original data space, and I want to now introduce this idea of aligning things into a common space. And so one commonly done thing with the mrTools is to have a high-resolution anatomy scan for a particular participant, usually 1 millimeter isotropic mrH scan, T1 weighted scan. And we routinely do segmentations on those with FreeSurfer, although people sometimes use Carrot and other tools too. But sort of FreeSurfer is a go-to tool. And so for this participant for which we have this sample data set here, I have run a FreeSurfer analysis. And so there's some important details here. The output of the FreeSurfer segmentation can be converted into a convenient format for aligning things to in mrTools. And so I'm providing those files and some details on how to get to that point with your own data sets on the GitHub page as well. So now the question is, how do we align everything into this common space, right? So the fMRI data for a particular scan condition was acquired with the imaging stack in a particular orientation in the scanner, and the anatomy images are usually obtained in a completely different convention using a completely different imaging sequence and geometry and so on. So in order to bring those two into register, we have to align them, okay? And mrTools comes with a tool called mrAlign, which we can type in here. And it's sort of a user interface. There's some documentation on the web page too. And so the general idea is that we have a destination image that we want to align to, and a source image that we actually want to align into this destination space. Okay, so on the file, you can select those two images. So the first step we'll do is as the destination, our ultimate destination, we'll use this T1 weighted mrH file, which I will show you in a second. So they are not actually usually stored in the data directory because we can use the same anatomy file for that one person across multiple scan sessions and usually only have one of them, and you reuse it. So the default location will be determined by your FreeSurfer install, but for now I've just included it one level up, and the folder here is called surfrelax, and there's a whole bunch of files in there. I want to use this mrH_PPP image. Okay, so the 5s here are a fake patient ID, so a participant ID that we would use in Nottingham. So there's a 5-digit numeric code that uniquely identifies a scan participant, but it's sort of pseudonymized. This one is fake, so and we haven't quite had 55,000 participants at this imaging center since we started using this convention. Okay, this image comes in. You can navigate. Don't be alarmed by the fact that this looks like it's rotated by 90 degrees. So for the images that we have acquired in our convention, this looks pretty standard, so that's normal. You can actually play around with this if you want, if this annoys you. And now the question is, can we align the anatomical image or the scan images that were acquired for this particular scanning session into this space? Okay, so that's going to be the source image that we have. And this one, I want to actually use this anatomy image that we have created from our EPI data, okay, just to see what that looks like. So scan number 3 was an anatomical scan that we collected separately. Scan number 4 is the anatomical image that was created from an fMRI data set by collapsing across time, as I've done showed in one of the previous videos. So I'm going to load that in, and let's see what the warning messages here are. So there's no base frame coordinate frame here. So one thing you can try when that happens is either set the alignment to identity, which will try and put everything into the common space. And you will see that it sort of puts it in the right size, but in completely the wrong place. You can sometimes try also initialize alignment from header. That sometimes works as well. So in this case, actually, that doesn't. So the way we've done the images. Okay, so let's go back and set it to alignment to identity. and that puts this image in roughly in the right data cube, because we haven't actually transformed the data. And now you can play around here by transforming in this window here by different pixels. So and you can explore what the actual orientations here are, right? So y direction points in this direction, so 15, and the z direction we probably need to add quite a bit, so maybe 50, 100. Usually this tool will pick up the correct alignment information from the scan, so we can switch to coronal view to see what's going on here. Right, difficult to see. Axial view, what's going on here. Sometimes it's useful to actually just blend the images by changing the transparency, right? So you can roughly see what's going on here. And you sort of get a general sense of what's happening here. Now at this point, when you have things in rough alignment, you can do the first thing, which is you can compute a coarse alignment. But because we are already doing something slightly unusual, which is matching a T2 star-weighted image into a T1 weighted image, we need to make mrAlign aware of that. So I'm going to the advanced alignment menu here. And we are trying to, so there's some various options here which are all documented, which you can explore a little bit. In this particular case, we're actually dealing with a sort of a difference in contrast. So there's a trick that's being used internally. So I need to tick this box here, otherwise the alignment will get set off in the wrong direction. Okay, so I'll say compute coarse alignment, see what happens. Okay, so actually this took a couple of seconds on my machine, 3 seconds, and it did a reasonable job. Okay, so you can see this is trying to align at a coarse scale, not a very fine, the images together, taking into account the fact that we are going across different contrasts. Okay, so there's an option to check the alignment, so you can do show mosaic, because these images are different contrasts, and normalization had to be done. And you can see here, this is an image from the anatomical scan, this is the EPI data, and this is a checkerboard merged image where we've tried to match them together. Now, one thing to look out for in alignment in general is to make sure that sort of the gross landmarks in the gyre and sulci match up, because it's quite common that there's a left-right flip in the data, and you want to avoid sort of being stung by that. So I quite often look at the shape of the ventricles, the major gyri. It looks like, in this particular section, this fissure looks quite big here, and it's visible there as well, so hopefully that works. Okay. So now that we've done that, I'm going to actually go to compute the fine alignment. So that's going to be a little bit more precise. It looks like there's also one of the GUIs threw up an error here, which we'll investigate at some point. And so the fine alignment actually looks like it wasn't very far off, so it didn't have many iterations to do. That's fine. Okay. So at this point, we can save the alignment. So that will save it back into the file into the source file that you're trying to align into the destination space. But we also need to let mrTools know about the updated information in its internal data structures. Okay, so it's an important step not to miss. So you can say export Mr. Loader to 4.5, the version. And because we are running in this folder where there's an alignment, where there's data structures present, it will ask us to double check. We're going to do that. Yes. And if we have one or more groups here, you can also select which one of them, which one of the groups you want to update the alignment for. In this case, I actually want to do it to all of them. Okay, so the motion comp in this particular case will inherit some of this alignment information, and they can then get updated to make sure that everything works nicely. So the default settings are okay here. Just doing some stuff. If you've already had an base anatomy loaded in the Mr. Loadred GUI, then because the alignment has changed now, it needs to be updated. So the clean way to do that is to remove it from the view. This doesn't delete it, it just removes it from the Mr. Loadred session. You can load it back in again with the updated settings. I'm going to say okay, yes to that, so we don't get any weird problems. And then I'm going to close this, okay? So I say quit here. Home to make a bit of space here, just to show you where I'm in this folder here. And I'm now going to start the Mr. Loadred window. And because we deleted this base anatomy file, there's nothing present now. But so one thing I can do now is I can choose which anatomy to load. So in this case, I can load back this scan number 4, which was our previous sort of faked anatomy scan. Right, and it will display this analysis which was loaded on the thing here. And if I've done things correctly, if I load in a second anatomy now, which is a second anatomy file, which is going to be the one that we used as a sort of final destination point, hopefully things will be in register there. And you can see how things are aligned in that space. Okay. So let me switch to the coronal view and the sagittal view just to check that these things are fine. And so you can now see actually the position of the scan data, which is this blue rectangle here, on top of the anatomy scan for this particular person. Okay, and these two things are now in register. So there's a couple of cool things about the way this is actually implemented, which is that sort of the rotations and the interpolation for displaying the data are only applied for visualization, right? So the code leaves alone the actual data cube, so there's no resampling or interpolation that happens to the data. For doing any of the calculations, they always happen in the scan space, unless you do some extra steps. But for looking at whether things are aligned properly, this is now very nice, because we can look at things with respect to the anatomical structures that are visible from the high resolution and anatomical scan, which is usually a much nicer way of looking at where things are positioned than sort of the slightly coarser fMRI data. Okay. The other win is that FreeSurfer produces some extra surfaces. I'm just going to try and attempt that. So we can import, actually we can, under base anatomy, import a surface. And so I need to go back to this anatomy folder. And let's say I'm interested, so you need to do this one hemisphere at a time. So I'm going to load in the right surface first. So the convention is you need to give it the gray matter file. There's some of the titles are actually missing of these of the windows. So you need to know that to pick the gray matter, not the white matter. And it pops up this interactive window here. It tells you that the gray matter surface is being used. There's some options about which surfaces to use for display and actually sampling the underlying data, which I will explain in a later video in the anatomy. So all of those things look correct for now, so I'm just going to press OK. And because the FreeSurfer surfaces are in the same space as the anatomical images, we can now look at things on the surface view as well. Okay, so if I change, for example, the threshold of the statistical maps, it will only display them in the appropriate locations. And so this is a very nice and straightforward way to switch between views in surface, high resolution, anatomical, or scan space respectively. Okay, and because each of those things are now in register, you can actually find out where things are located in these different kinds of spaces. Okay, so if I switch back to the MPRH space, and I say interrogate overlay, and you pay attention to the fields at the bottom here that show the coordinates, you should now be able to see, if I've done this correctly, the coordinates update in the different spaces, right? So where are we in scan space, in the actual anatomical space, and so on. Okay, so here we go. Right. So I'll stop the recording here, and we'll go into a little bit more detail how we could use this information in our analysis, in scripting, and writing interrogate functions next.